Hi, I'm Dr. Groff, and this is Physical Computing. This course is about electronic devices and how to program them. This is one of my favorite courses to teach, and in some way you're going to find it different than any course you've ever taken before. For many of you, programming, electronics, these are topics you have no experience in, and I want to let you know that the course is designed without assuming that you have any experience in electronics or computer programming. My hope is that you find the material fun and challenging, but at the end of the semester you find that you have an increased sense of empowerment, that you can take an idea and you can create it, that you are a maker. So what is physical computing? My definition of a physical computer is it's any electronic device, usually a digital electronic device, that can interact with the physical world. Importantly, this means interactions are reciprocal. So a physical computer must have the ability to both sense stimuli in the physical environment and respond in some way to those stimuli by modifying the physical world in some way. So this digital thermometer here and humidity sensor senses the world around it, but it's not really a physical computer. It displays information, but it doesn't modify the environment where it's situated. All right, so it's a digital sensor, but not a physical computer. In the same way, a light is capable of modifying the environment by providing light, but it's not a physical computer because it doesn't sense and respond to the environment around it. It doesn't have that ability. But let's go over here. This right here is a digital thermostat, and it is a physical computer. You can create a set point, and if the temperature drops below that set point in the environment, it responds by turning on the heat. And in the same way in the summer, you can have a set point, and if the temperature goes above that set point, it turns on the air conditioner. So it is sensing and responding to the environment in which it's situated. So it is a physical computer. And when you start thinking about electronic devices in this way, you'll see that there's physical computers all around us. You should spend some time looking around your house and the school and looking for physical computers, and you'll start to see them everywhere. They're increasingly important in our lives. Consider the recent proliferation of home automated devices like, hey Alexa, turn on the light. Like that. Those of you who are environmental studies majors, your studies are concerned with better understanding humankind's interactions with both our natural and the highly modified built environments that we create. In this context, you see the value of learning about physical computers because they allow us to gather information or data about our environments, but also to modify our environments in important ways. One example, particularly exciting example, which some of you might get experience with while you're here, is using physical computers to enable what's called controlled environment agriculture. This is agriculture that's carried out in a greenhouse, usually, or some other indoor space where sensors sense and respond to the physical environment, controlling things like lighting, airflow, heat, cooling, even irrigation. So the applications of physical computers in the environmental fields are many and growing. All right, so welcome to the class. Let's get started.